Yeah, I like it. It feels good.
The following is a review of the manufacturing processes associated with the specialized stump jumper Comp Evo 650B.
The handlebar begins as a raw aluminum tube which was then likely drawn through a die and a mandrel to produce a varying wall thickness. This is evident by the varying diameter throughout the handlebars. The handlebars could have been hydroformed instead of drawn, but hydroforming would likely be more costly. After drawing, the tube would then be bent to final form. The rough surface finish and lack of evidence of paint spatter suggests that the tubing is likely anodized. This is also likely due to the importance of controlling the diameter of the handlebar's middle section. The size of the handlebar's middle section is a major GD&T concern in relation to the assembly of the bike. If the diameter is too small, the handlebars will be loose when assembled and can cause a safety hazard to the rider. If the diameter is too big, the clamps and the handlebar will be under increased stress. Parting lines and ejector pin marks can be seen in various places on the plastic pedals. These marks are characteristics of plastic injection molding. Upon melting a small sample of the plastic pedal, small glass fibers can be seen, indicating a glass-filled plastic which would likely be nylon due to the nylon's excellent toughness, availability, and common usage in similar parts.
The frame was likely made by hydroforming individual sections of aluminum tubing and then TIG welding the sections on a jig. Hydroforming is evident due to the varying cross sections in the tubing where a tapered profile can be seen. These complex shapes would be impossible with extrusion, tube rolling, or other similar tubing processes. The weld pattern can be seen at the end of each tube and appears to be welded by hand due to the non-uniform weld bead. The frame is painted with a typical spray coating rather than powder coated or anodized. This is evident due to the paint overspray on the underside of the steering head, which is absent in anodizing, and the fine metallic glitter in the paint, which is not common in powder coating. An alternative manufacturing process would be to create the frame in halves by stamping sheet metal and then welding the halves together. However, this would result in more heat-affected zones around the welds, resulting in decreased strength. The rear cassette gears have no signs of cutting processes and have varying angled chamfers on the gear teeth. A close-up look at the gear surface shows pitting and a wavy surface finish. These features suggest that the cassette gears were manufactured using powdered metallurgy. The shiny appearance suggests that the gears were zinc or nickel electroplated.
The rotor seems to have been stamped to form the complex shape. This is evidenced by the uniform shear marks seen on the edges of the rotor. Alternatively, it could be CNC machined. However, this is unlikely since CNC machining has slow production rates when compared to stamping. The rotor also seems to have been precision parallel ground as evidenced by the radial grinding marks on both faces of the plates. The company symbol markings on one side of the face appear to have been laser etched due to the appearance of laser marks on their high magnification.
The aluminum rims are likely extruded in the cross-sectional shape of the rim and cut to length. It's possible this is done using a roll forming process, but due to the additional tooling cost and complexity of the part, it is unlikely. The extrusion is roll bent into a circle the size of the rim being produced, and resistance welded as evidenced by the weld bead on the inside of the rim where post-machining would be difficult. The rims are then placed into a specialized CNC machine where the spoke holes are drilled at precise locations.
The rims are likely finished with an anodizing process to protect against corrosion. One is able to see scoring on the rim's surface, and unlike paint, which is thick enough to fill the minor imperfections, anodizing is generally under 1/1000th of an inch, thus leaving these imperfections visible.